All right, let's finish up variation functions. These are the, examples 4 through 7. A third type of variation describes a situation in which one quantity increases and the other decreases. For example, the table shows that the time needed to drive 600 miles decreases as the speed increases. This type of variation is an inverse function. This type of variation is an inverse variation. An inverse variation is a relationship between two variables, x and y, that can be written in the form, let's write that a little better, y equals k over x, where k can't be 0. For the equation y equals k over x, you'll see in the problems y varies inversely as x. Okay, let's try one. Y varies inversely as x, so I'm going to write y varies inversely as x, and k goes there. And when y equals 4, x equals 5. Okay, we solve for k, multiply both sides by 5. That's a multiplication. 20 equals k. So write your inverse variation function. Y equals 20 over x. Done. You try one. Given y varies inversely as x, and k goes up there. You try the rest of it. There we go. Pretty simple. Okay, when you want to find specific values in an inverse variation problem, you can solve for k and then use substitution, or you can use the equation derived below. So if we have y varies inversely as x, you can solve for k. Y varies inversely as x, solve for k. Therefore, y1x1 equals y2x2. We're going to do the problems both ways. The time t needed to complete a certain race, t, varies inversely as the runner's average speed, s. T varies inversely as s. K goes on top. If a runner with an average speed of 8.82 miles per hour completes the race in 2.97 hours, what is the average speed of a runner who completes the race in 3.5 hours? So first we're going to do the method where we find k. Okay, we have time varies inversely with speed. Okay, solve for k, multiply 8.82 on both sides. I didn't leave a lot of room here, so we'll write it like this. 2.97 times 8.82. I have k equals 26.2. Continue the problem. What is the average speed of a runner who completes the race in 3.5 hours? So time varies inversely with speed, and you know that k is 26.2. If we solve for s, I'm going to multiply both sides by s. I get 3.5s, 26.2, divide, typo there, sorry, by 3.5. Divide both sides by 3.5, and s equals 26.2 divided by 3.5. 7.5, approximately. Okay. The other method, T1S1 equals T2S2. So I believe our first time was 2.97. And our first speed was 8.82. Our second time was 3.5, and we don't know our second speed. 2.97 times 8.82, 26.2 equals 3.5 S2. Divide both sides by 3.5. And we get S2 equals 7.5. And there is our answer. Okay, you go ahead and try this one. Push pause and do the whole thing. It's an inverse variation, so set it up correctly. We're going to do it finding K first and then using the proportions. Okay, there we go. First time we tried it. Time varies inversely with the number of volunteers. Let's try it again with the proportion. Go ahead and try it again. Push pause and crunch the numbers. There we go. Moving on. All right, you can use algebra to rewrite variation functions in terms of K. So our direct variation function K is y over x. This would be your constant ratio. For the inverse variation, K is x times y, and this is your constant product. Notice, ratio is the fraction, product is when they're multiplied. Okay, and reading down here, it says, notice that in the direct variation, the ratios of two quantities is constant. In the inverse variation, the product of the two quantities is constant. Your variation constant is always constant. It's a number. It doesn't have any variables in it. So our constant ratio, you divide them, and it's a constant ratio, constant product. Determine whether each data set represents a direct variation, an inverse variation, or neither. All we're going to do here is multiply them and divide them and see which one is constant. So first, for this first one, let's try y over x. Okay, I'm going to take 0.5 divide by 104, and I get 0.0048. 4 divided by 13, I get 0.308. Okay, doesn't work. I'm going to erase those. Let's try x times y. 104 times 0.5 gives us 52. 13 divided by 4. Hey, it's 52. Just triple check. 6.5 divided by 8 is, 52. So the product is constant. So this is an inverse variation because the product was constant. Let's try B. First, let's try x times y. So I get 12 times 72. 864, 8 times 48, 384, no, doesn't work. Erase. Let's try y over x. 72 divided by 12, 6. 48 divided by 8 is also 6. Triple check. 30 divided by 5 is 6. It is a direct variation. Let's try this last one. Okay, let's try xy. 8 times 21 is 168. 6 times 14, 84, doesn't work. Let's try y over x. 21 divided by 8 is 2.625. 14 divided by 6 is 2.33. Doesn't work. So neither is the answer. Okay, you try this one. Okay, try both variations and see which one works. There we go. The first one, the direct variation did not work, so it was in fact inverse. The second one, the direct variation did work. That's what it is. Good job. All right, combined variation, a relationship that contains both direct and inverse variations. Quantities that vary directly appear in the numerator. Good thing to remember. Quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator. The change in temperature of aluminum wire varies inversely as its mass, m, and inversely as mass, directly as the amount of heat energy, E, is transferred. Okay, so the change in temperature varies inversely with mass, directly with energy, and we have a K there too. Okay, signifying change in temperature, we're just going to put a little delta there, that's a symbol that means change. So the temperature of an aluminum wire with mass 0.1 rises 5 degrees Celsius when 450 joules of energy heat are transferred. How much heat energy must be transferred to aluminum wire with a mass of 0.2 kilograms to raise its temperature 20 degrees C? So let's solve for K. I'm going to multiply both sides by 0.1. Actually, no, I'm going to divide 450 divide by 0.1. And I get 5 equals 4,500 K. Divide both sides by 4,500, and I'm left with K equals 0.001. We're going to use that K to solve for the energy. So I've got a change in temperature of 20. 0.0011 is K. We don't know the energy, but we know that the mass of wire is 0.2 kilograms. Okay, so 0.0011 divided by 0.2, and I have that is 0.0056. Divide both sides by 0.0056. 20 divided by 0.0056. Energy is 3,571 joules. Pretty cool. You can actually round that if you'd like, but I left space for another one. Okay, blank slide. You can doodle with that one. Okay, you try with this one. Volume of gas V varies inversely as the pressure and directly as the temperature. So volume inversely as pressure, directly as temperature. K goes right there. Okay, so go ahead and finish it. So to finish up this problem, first we solved for K by plugging in the temperature, the pressure, and the volume. We got K as 0.05. Then we use that K with the remainder of the information, the temperature and the pressure, to solve for volume, which is 20 liters. And again, a blank page. Looks like a car. I'll see you guys tomorrow. Good job.